In a world where new and innovative technologies seem to be making a debut every day, and where the IT arena is bombarded by new ideas and concepts relentlessly, there is a growing pressure to release innovative software to rapidly meet the demands of our day. This holds true for in-house development projects and, of course, for commercial software houses who are constantly trying to create new and innovative products to wow us, to wow this very fickle consumer base. However, in this hectic environment, even in this hectic environment, how does one set standards for quality in relation to any IT products that are coming out? Who can ultimately define whether or not a software product is good enough and robust enough to meet our needs? Robust enough for general release to the end user? Who actually certifies that this should be released? When asking such questions, we've already entered the realm of quality assurance and software testing. This is a huge area of IT recruitment, so we should look at that now. So what is testing? Well, testing is the process of identifying and correcting errors which might exist in, let's say, an IT software or any IT system. Oh, by the way, testing is not a certification that the system is completely free of bugs or errors, because actually that's pretty much impossible. It is impossible to ensure that the enormously sophisticated software applications of today are going to be 100% bug-free. Realistically, all the testing can do is go some way to assuring us that the software will perform its key activities without any major errors. Next, it's also worth appreciating the key differences between the nature of software errors and hardware errors at this stage. I'm not going to dwell on this, but I just need you to understand this. It's quite fascinating, and it's probably something that you've not really thought about. The idea that hardware and software errors are very different in nature. So for example, things like hard drives and motherboards, they're more likely to fail as time goes on because of wear and tear. So hardware is very different from when it was brand new to when it's used. So there is more chance of it failing and errors appearing as we go on with time. Now that shouldn't be the case with software. Software faults seldom suffer the problems of wear and tear as time goes on, with the obvious exception of things like viruses and attacks. But generally in software, the errors are always there. If they exist now, then they've been there from the initial design stage, and they were a design flaw. New flaws in coding won't spontaneously appear with more and more usage. They shouldn't. Software doesn't spontaneously mutate. If there's a problem in the code, the likelihood is it's been there since the beginning and it was a design flaw. Now, simply put, there is a clear, simple economic logic to actually doing software testing and making sure you've got it right in the first place. Studies over the last 10 years have shown that the defect that is discovered during the early coding stages of software, which might cost $1 to rectify at that stage, will, if untreated, cost $1,000 to repair later on in mass production and in supporting that software during the course of its life. So it makes sense to get software right from the very beginning. Now, once again, software recruitment is a deep dive, and I've got masterclasses on that. We're not going to do that here, but what I am going to do is make sure that you understand the idea of two huge umbrella terms within software testing. If you've got this under your belt, you're pretty much away with software testing. So, there are two terms you often hear bandied around by people you're recruiting for, the company or the IT division, and the candidates you speak to in this field. And these are black box and white box testing. So let's look at these. Now, black box testing is the catch-all term for any type of testing that focuses on the external behavior of your software. It's another term for testing that really just puts a focus on how the software behaves on the outside. In other words, does it do what it's supposed to do? That really means that you and I could become black box testers for the software that we're currently using. And that is generally true. The other name for black box tester is user acceptance tester. Okay, so you could have power users within the organization who have been hired to be the UAT testers for a particular product because they will test drive it and they'll put it through its paces and then they will tell you what is wrong with it. But they won't be able to lift up the bonnet and look inside and see what's gone wrong. White box testers are the ones who are far more interested in opening it up, looking at the innards and seeing where it went wrong, how it went wrong, what part of the software failed, and how do we need to tweak the code in order to fix this problem. I hope that makes sense. By the way, this particular division within IT is really known for the number of different ways they can say the same thing. Another name for black box testing is functional testing, and another name for white box testing is glass box testing. So it's interesting. There's a lot of interchangeability there. Another term for white box testing can also be technical testing, non-functional testing, and structural testing. So I really didn't want you to get weighed down with all these different test types. Just understand that there are two big umbrella terms, black box and white box, and the things you're going to see on job specs and CVs pretty much fall into one of those remits.